All right, so here we're looking at natural gas production, historic. So the table shows the estimated production rate of marketed natural gas in trillion cubic feet per year in the US, excluding Alaska. So we're supposed to find a model for the data in the table, then use the model to estimate the total production of natural gas from 1940 to 1960, and then write the definite integral notation for the answer to part B. All right, so let's go use our calculator. And as you know, I'm going to have all the data entered. So basically, we just have to look at the graph. I checked that point just is high, but that kind of looks like an exponential. So let's try an exponential and see what we get there. I think that's a 0. Yep. All right. So then we can do alpha 1 and then calculate. So that looks good. Let's see what it looks like over here. Yeah, I think with that point, and those 2 points are kind of just a little oddballs, so that's just going to be the way it is. And so our equation is 0.161 times 1.076 to the x. All right, so we end up with our function is A is, let's call it P of T equals 0.161 times 1.076 to the x, and that's trillion cubic feet per year. Okay, and it's from 1900 to 1960 if we wanted to write all that out, but we're just going to put that for now. B, use the model to estimate the total production of natural gas from 1940 to 1960. Well, if we look, it was all above our axis. So from 1940 to 1960, we can just take and do the integral. So let's do that. And we can do, the easy way. We can just say, okay, we're going from 1940 to 1960, and then we can go over here and say, well, since we already put in y1, we can then say, okay, well, let's then put vars and then 1, 1, and then we can put our x, and this should give us our value. So 138.338. So what we are doing is we're taking the integral from 1940 to 1960, and that's going to be of 0.161 times 1.076 to the x, and then that's dx, and so that gave us 138.338, and we drop off the per year, so that's trillion cubic feet. So that's how much we have, okay? Now we're supposed to write the definite integral notation. Well, you know what? We just did that up here. We went from 40 to 60 of 0.161 times 1.076 to the x, and then dx, and that's our integral notation. Although, we had t's, we switched it to x's because our calculator said x, so I switched it there, but it's t's. Maybe we should just switch that to x, and then we're good. We won't have to worry about it, okay? So that's all we needed to do there. So that one was a fairly simple question, and we just had to figure out the equation to use there. All right, what the next one says, gender ratio. So the rate of change of the ratio of males to females in the US from 1900 to 2000 can be modeled as blah, 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 males per 100 females per year, where T is the number of years since 1900. So we're supposed to evaluate and interpret. So we need to find all those. Well, guess what? Let's just plug those into our calculator and see what it says. So we're going to write that in here, and we'll say y is equal to, now let's turn our plot off so we don't have that going. And so y is equal to, it said 0.2274 sine, and then it was 0.0426 x plus 2.836 in parentheses. And so if we wanted to see what it is, I don't know if it's even in the right scale here. No, it's not. So we'd probably do from -5 to 5 by 1, and we can go from -5 to 5 by 1, and let's see if that makes it so it's still not small enough. So yeah, so let's not worry about it. We don't care what that is. So what we want to do though is we want to do the integration. We don't want that. So we want math 9. And so as first one said, go from 0 to 40 for our y1, and then we want x, and so we get our value, negative 4.175, all right? So this is equal to a negative 4.175 males per 100 females, okay? And we were not interpret it yet. We'll write all the numbers down, then we'll interpret it after that. And then we had to do one, and it was going to go from 50. Well, actually, let's do the last one. It was from 0 to 10, so then we can just change that one number. 0.209. So then this is 0.209 males per 100 females. And now we want 50 to 100. So 50 to 100, negative 2.330 males per 100 females. All right, so interpretation. So this one was from 1900 to 1940. So from 1900 to 1940, the number of males per 100 females decreased by 4.175 males per 100 females, okay? B, well, it's still a negative, so basically it's the same thing. So then here from 1950 to 2000, the number of males per 100 females decreased by, and we have 2.330 males per 100 females. And then part C says, well, guess what? We have an increase this time. So from 1900 to 1910, the number of males per 100 females increased by 0.209 males per 100 females, okay? And again, we're using our calculator to calculate all these. So, you know, it's not like we're actually doing the integration. This one would be a little harder integration because you have to remember it's going to be that times, then we have to do the negative cosine, and then it's going to be of this over the 0.0426. And so it's going to be a little bit more stuff to do. But, you know, all the rest of these, when we did this, we could have easily taken the derivative of that, and that's going to be 0.161 times 1.076 to the x over ln of 1.076. So, you know, things aren't hard, but you need to practice both doing it with the calculator as well as knowing how to do it by hand, as taking our antiderivatives. Okay, and that's all I have. So hopefully that helps.